Welcome back. This is an Aleks training video on understanding the common modes of radioactive decay. So there are four basic modes of radioactive decay. The first one is alpha emission. And alpha emission, if you emit an alpha wave, you're actually emitting matter. You're emitting the nucleus of a helium atom. If you remember, helium is 2. Charge of 2, it's plus 2 because there's no electrons here, and it's a mass number of 4. So that means your Z, okay, your charge will go down 2, and your A, your mass number, will go down by 4, okay, as it goes from left to right to the daughter nuclide, okay. So as it goes from left to right, your mass will drop 4 and your charge will drop 2. So let me just write that down and then we'll do it together. Your Z drops 2 as it goes from left to right. This is a Z. Okay, Z drops 2 and your mass drops 4. Okay, a beta wave is really just an electron. Okay, it's a very high speed electron. So it has a charge of -1. It has no mass. It's basically no mass. And so your Z, okay, is going to do what? Well, if you spit out a -1, that's the same as adding a charge. Your daughter nuclide will actually add 1. But since the electron has no mass, your A will stay the same. And the next one is positron. Positron emission. A positron, gives me a headache. A positron is something on the order of a positive electron. It's just backwards in charge. So it's a +1, but it still has no mass. So think of it like an electron, but it's a positron, a positive electron. In that case, if you spit one of these out, your Z is going to drop by 1. But your A stays the same since it's 0. Stays the same. The last one is a little bit different. It's going to capture an electron. So this means that the electron is going to be on the left. It'll be on the reactants. So this is called electron capture. Okay, so you'll have the nuclide, and then adding an electron on the left, then you're going to have your arrow, then your daughter nuclide will be on the right. So since you're adding it, then your Z is going to drop 1, okay, because it's on the left, and your mass stays the same. Now, if you'll look, both of these, Z drops by 1 and A stays the same. Electron capture, you've got an electron on the left. And positron emission, you have a positron on the right. You're emitting a positron. So the accounting works the same. If you add a positive in the products, then your Z is going to go down by 1, or your original has to go down by 1. We'll just do this together, okay? All right, so let's look at what you're asked. You've got electron capture, okay? So electron capture means you're going to have something. You're going to have something. I don't know, something plus an electron. So we're going to have an electron on the left. So something like that. Then you're going to have your reaction. You're going to have your daughter nuclide. So you're going to have, it tells you, sorry, you've got O8, 17. So you have oxygen 17. Right. Electron capture is always going to send out an alpha or a gamma radiation, which doesn't do anything to the numbers. It's just there's always a high beam of electricity there, or energy there. So what do we got? We have to drop down. Okay, we're staying the same at the top. So whatever this is going to be 17. Okay, because when you add 0 to 17, you're going to get 17. So the top will be 17. What will the bottom be? Okay, I need something minus 1 equals 8. That means I need 9 minus 1 equals 8. Well, what is 9? 9 is fluorine. So this must be fluorine 17 plus an electron. Adding an electron will drop that down. So the electron essentially, you pull in an electron and it steals one of your atomic numbers from fluorine down to oxygen 8. Okay, so that would be oxygen 17 as a thing. What is your second one? Okay, beta. All right, so you start with technetium 99. Technetium is 43. Okay, and you are going to emit a beta. So emitting will be a -1, here 0. All right, so that means that it still has to be 99. 99 is the mass number because 99 equals 0 plus 99. What do we have? We have 43 equals minus 1 plus something. What minus 1 equals 43? Well, it has to be 44. Okay. And 44 on the periodic table, ruthenium. Okay, so this has to be ruthenium 44 or ruthenium 99. Okay, that would be your second one. And what is your third one? Carbon 14. Carbon is 6. And we don't know what it is yet. We don't know what it is, but we know that the daughter nuclide is going to go up to nitrogen and stay 14. Okay? Well, that means that 14 plus something is 14. Okay? So that means it has to be 0. Something is 0 on the top. 7 plus something equals 6. So that's a -1. So it must be an electron. Okay, -1, 0. So I would say this is beta. It makes me think that's beta. So this is going to be beta emission. Okay. This is going to be ruthenium 99. And what was the original one? Fluorine, which was 9, and it went up to 17. Fluorine 17. Okay. This will give you a headache. Hope you have a good day.